Welcome back, guys. We're going to go over the guided practice right now. If you did it and you want to see how you did, here are the answers on the side. Guided practice, page 268, numbers 1 through 5. The answer for number 1 is 8. Number 2 is 1.5. Number 3 is 4 1/8. And 4 is 3 6/7. Number 5 is 10 year. Now, I want you to notice something. All of these answers are mixed numbers or whole numbers. There are no improper fractions. So when I give you the quiz, make sure if you have an improper fraction, you change it into a mixed number. Okay? Or whole number. Whole number, mixed, mixed, mixed. Whole number. You'll have to look at what you have in front of you to decide which one's which, okay? Which one to use, I'm sorry. All right, anyways, let's get started. Number 1. Okay, now here's the deal for number 1. You have a whole number times 4/5. The reason I'm saying this because if you start with a whole number first, if you're going to draw an area model, I suggest you draw 10 bars first and then break up those bars into 4/5 into fifths and then shade in 4, right? Now, if it was the other way around, if it was 4/5 times 10, I'd ask you to draw the fraction first, an area model for that, shade in 4 parts out of 5, and do that 10 times, okay? So it really depends on you how you want to do this. Remember, the commutative property says the order doesn't matter. You'll get the same product. But with a word problem, it might matter a little bit only in how you make a drawing if you decide to draw. More on that later. But here we go. Follow my own advice. Now, one other thing I want to add. Because of the time it takes to draw an area model, I'm only going to do this for number 1. Okay? For 2, 3, 4, and 5, I'm just going to draw a equation. Write an equation. Okay? Maybe for the word problem, I'll draw a picture out, as always, because I like to draw pictures for word problems, so I understand what I have to do. But anyways, here we go. 10 times 4/5. 10 holes. Ideally, this would be the same size. My rectangles would be the same. All the parts would be equal. But because I want to finish this quickly, again, this is just math. It's not supposed to be an art project, not yet. Maybe later it will be, but not right now. So here's my 10. My 10 holes. Let me just count to verify. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. I'm going to make a situation here. I have 10 pizzas. I'm going to cut them up into slices. I'm going to cut them up into fifths. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. If you do something different, then that's fine. Or maybe you didn't draw anything at all. You just went ahead and did equations. There's nothing wrong with that. 1, 2, 3, 4, 5. 1, 2, 3, 4. Nothing wrong with that at all. But make sure you understand the idea of what you're actually doing when you're multiplying by fractions, okay? Because right now these fractions are easy. It does get harder. But anyways, there's my 10 holes. Each one, I only want 4 parts out of 5. It's like saying, okay, I only want 4 slices out of the 5. Almost all of it, but not quite. So with what I just said, you can see the answer is going to be less than 10. I'm not getting all full 10 pizzas. Okay, it's like saying, okay, my dad gives me money. He tells me, okay, I want you to buy 10 pizzas, but you're not getting all of it. You can only eat 4 slices out of the 5. So, I know it's kind of greedy, right? It's just an idea, guys. But what I'm saying is the answer will not be 10. It'll be something less than 10 because I'm multiplying times something less than 1. I want less than this, or I'm going to get something less than this. So here's my 10. I only want 4 parts out of those 5 slices. For every 5 slices, I only want 4 of them. Again, 4/5, 4/5, 4/5, 4/5. Part to whole. Again, look at the denominator. I'm making sets of 5. I'm making sets of 5. Now, how many parts do I actually have? 4, 8, 12, 16. If you can just see, I'm just skip counting. I'm adding 4. 4 plus 4 is 8, plus 4 is 12, 16, 20, 24, 28, 32, 36, 40. I have 40 parts, right? So, incomplete sets, right? If I were to take all those slices, I have 40 different slices, and I put them all together, trying to make a full pizza. How many full pizzas would I have? Well, according to this, I'd have 8 full pizzas, right? I'm making sets of 5. I have 40. 40 divided by 5 is 8. Okay. Let's do the equation just to get that done. I'm going to change the whole number into a fraction by putting 1 under it. Again, 10, numerator times numerator, 10 times 4 is 40, 5 times 1 is 5. Same thing, we just did the math, it's 8. Okay, so for the rest of them, I'm going to do the equation with except number 5. I might actually do an area model for that. So when we have our Zoom meetings, if you have questions, please ask and I can draw the area model if you want to make sure, if you want to see how it works. So here we go. 2 times 2/4. Okay. In the directions it says write in simplest form. From this point on, always assume you have to simplify. Unless the directions say don't do it or the teacher says don't do it, always simplify. Okay? So anyways, 2 over 1, 10, you're going to see that I'm going to go a little faster because I think most of you get the equation part. 2 times 2 is 4, 4 times 1 is 4, 4/4 is just 1. Whoop. Guess what? The answer's right, but I did something very, very wrong. And it's something I tell you guys to always do, and I didn't do it myself. Make sure you copy the problem correctly. The whole number's correct, but the fraction I had to copy was 3/4. So my math is right. It's the right answer for the wrong problem. This is what we had to do. I'd like to say I did that on purpose, but I did not. I goofed up. Went too fast. Lesson for all of you. Don't go so fast to make silly mistakes. Because on the day of the test, you can't tell me why I copied the wrong thing. Because I'm going to tell you, well, you start taking your time. So, for my own advice, there we go. I should have taken my time and done this right. All right. Numerator times numerator. Denominator times denominator. Okay. I'm making sets of 4. I have 6. I'm going to divide. I have 1 and 2/4. But since I have to simplify, the 2 and the 4th have a common factor of 2. The actual answer is 1.5. Okay? I will not accept this. Remember that. That's an improper fraction. Nothing wrong with it, but technically I want this better. That really goes with the definition of what a fraction is. I have a whole number and a part of something else. All right. Number 3. By the way, as a reminder, I know I keep doing this, and you hardly ever see me do anything here on the side. This is more for you, okay? As you look at the notes, as you copy the notes, and you notice things for yourself, pattern that maybe I didn't mention, or maybe you have a thought of a different way of doing this, take advantage and write this on the side. Hey, or if it's a question for me, I don't understand where you got this, or whatever it is. Questions, observations, ideas, this is where you write them. And you can ask me during the Zoom meetings. Or in class. If we were in class, but no, that was just a fleeting idea. 3/8 times 11. Again, if I were to draw an area model, I'd draw the fraction first. I draw a whole model with 8 pieces, right? Sets of 8s, and I'd shade in 3, and I'd do that 11 times. But this is what we have, 3/8 times 11. I'm going to do equation. 3/8 times 11 over 1. Numerator times numerator. Denominator times denominator. I'm making sets of 8. I have 33 parts. How many full sets do I have? Because you know I'm going to have more than one. Okay. Times tables. 8 times 1 is 8. Times 2 is 16. Times 3 is 24. Assuming you don't know your times tables, just do what I just did in my head or out loud. 8 times 1, 8 times 2, what do you get? I can make 4 groups of 8. That gives me 32. Okay. I have 4 full sets of 8 with 1 left over. Okay. 4 1/8. Again, mixed number. No, yes on the quiz. Okay. 3/7. I have something less than 1 times 9. My answer is going to be less than 9, right? And again, I'm just going to do equations just because those are fast. But when we get to the word problem, I might change that a little bit. Okay. 3 times 9 is 27 over 7, right? Numerator times numerator, denominator times denominator. I'm making sets of 7, but I have 27. My dividend is 27. My divisor is 7. My quotient, I can make 3 groups of 7, which gives me 21. I have 6 left over. So 3 full sets with 6 parts left over out of 7. Remember I said earlier, always look at the denominator. Unless you simplify, it's going to show up again in the answer. Okay? Denominator. Okay? Number 5. Oh, the word problem. Let's see what happens. I might actually have to draw something. A cat spends 2/3 of its life asleep. If a cat lives to be 15 years old, how many years did it spend asleep? Okay, all right. Okay. I'm going to compromise here. I'm going to kind of draw a fraction, kind of draw something. A little area model, but not quite the way you think. Oh, jeez. What I'm trying to do is draw, some of you might already guessed, he's trying to draw a cat. Trying. You know what? Doesn't hurt to draw. Okay, so here's my cat. All right. For every year of its life, every year, if you were to cut up that year into 3 parts, two-thirds of that life would be, according to the problem, asleep. That means this part would be awake. 1/3 awake. Now, the problem's not asking for that, but I'm just thinking ahead that if there were a problem where I'd have to know how long it was awake, it'll help. So for every year, if we cut up that year into 3 parts, and actually we can do that. A year would be 12 months. Each part would be 4 months, but that's more on that later. For every year, if you cut it up into 3 parts, 2 parts would be asleep, 1 part would be awake. Okay, but it's saying this, if a cat lives 15 years old, to be 15 years old, so we have 2/3. We start out with a fraction, 2/3 asleep. I'm not going to draw that 15 times, guys. I mean, you can do that if you want, right? 2/3 times 15, right? I'll do this as a compromise. Draw this 15 times. Yay! Okay. Change that whole number to a fraction by putting 1 under it. Later on, there's a different method I can show you to simplify before you multiply, but that's more on that later. I just want you to understand the idea. Numerator times numerator is 30. 15 times 2 is 30. Denominator times denominator is 3. I'm making sets of 3. I have 30. That means I'm dividing 30 by 3 because I know my times tables. It comes out to 10. But 10 what? What are we talking about? When you have a word problem, you have to identify what we're talking about here. We're talking about years. For every year, every 1 year, you divide that year into 3 parts. 2 parts of it would be the cat's asleep. The other part of the year, the cat would be awake. Now, it's just a word problem. It's not saying for 2 parts out of the year, the cat's asleep forever. It doesn't wake up until this part of the year. That's not what it's saying. But if you take up all those hours and divide it evenly, and so forth, it's just saying, it's the equivalent of saying, hey, this cat's actually asleep for 10 years. Anyways, hope that made sense. That is the guided practice.